Right now, while you are watching this video, thousands of things are happening in the background that you will never see. A streaming service somewhere is deciding which video to show you next. A bank is processing hundreds of transactions every second. A ride-sharing app is calculating the fastest route for a driver who is 3 blocks away. A social media platform is delivering a post to 50 million people in under a second. All of these things happen reliably, quickly, and without you having to think about them. And the reason they work so smoothly, the hidden reason, is something called software architecture. In this video, we are going to answer 2 questions that seem simple but have enormously important answers. What exactly is software architecture? And why does it matter so much? We are not going to use complicated language or dive into dense technical detail. Instead, we are going to use real stories, familiar examples, and simple analogies to understand one of the most important ideas in the world of software. Whether you are a student, a working professional, or simply someone who is curious about how the digital world is built, by the end of this video, you will see software in a completely different way. Let us get started. To understand software architecture, let us start somewhere unexpected, a city. Imagine 2 cities. The first city was built without any planning. Roads were added as people needed them. Buildings went up wherever there was empty land. Water pipes were run wherever seemed convenient. After a few decades, the result is a tangled, confusing mess. Traffic jams happen constantly. A broken water pipe takes weeks to find because nobody knows where all the pipes are. Building a new road means digging up several others. The whole city is expensive, slow, and frustrating to maintain. Now imagine the second city. Before a single building was constructed, planners sat down and made important decisions. Where would the main roads go? How would the neighborhoods be arranged? Where would power lines and water pipes run? How would the city expand as it grew? What happens if one road is blocked? Is there always an alternative route? The second city is organized, logical, and easy to expand. Everyone who works in it understands how it is laid out. Problems are easier to fix because the design is clear. Software architecture is exactly this kind of city planning, but for software systems. Before any code is written, a software architect makes the important decisions that will shape the entire system. How will the different parts of the software communicate with each other? What happens when one part fails? How will the system handle 1 million users instead of 1,000? What rules will the whole team follow when building it? These decisions, made before a single line of code exists, determine whether a software system becomes a well-planned city or a chaotic, unmanageable tangle. Now that we have the intuition, let us give software architecture a clear definition. Software architecture is the high-level structure of a software system. It describes the major building blocks of the system, how those building blocks are organized, how they communicate with each other, and the principles that govern how the whole system behaves and grows over time. Think of it this way. When you look at a house, the architecture is not the color of the walls or the type of light bulbs used. The architecture is the foundation, the load-bearing walls, where the rooms are placed, where the doors and windows go, and how the plumbing and electrical systems run through everything. Those are the structural decisions that cannot be changed easily later without a major disruption. Software architecture is the same kind of thing. It is the set of deep, structural decisions that shape everything else. Individual lines of code can be changed anytime. But architectural decisions, how the system is divided into parts, how data flows between those parts, where data is stored, how security is enforced, these are much harder to change once the system is built. This is why the software community says that architecture decisions are the most important decisions in a software project. They need to be thought through carefully before the building work begins, and it is also why when these decisions are made poorly, or not made at all, the consequences can be severe, expensive, and sometimes catastrophic. To truly appreciate why architecture matters, it helps to see what happens when it is ignored or done poorly. Imagine a small startup that builds a website. In the beginning, there are just a few hundred users. The team builds things quickly and informally. When a new feature is needed, they add it on top of whatever already exists without stopping to think about how it fits into the bigger picture. This works fine when the product is small. Then the product takes off. Users grow from a few hundred to 50,000, then to 1 million. The system starts to crack under the weight of its own complexity. Adding a new feature now means touching 10 different parts of the system, any one of which might break unexpectedly. Fixing one bug creates 3 new ones in parts of the system that seemed unrelated. The website crashes during busy periods because nobody planned for high traffic. Engineers who are new to the team take weeks just to understand how the system works. Every change carries enormous risk. This phenomenon has a name in the software world. It is called technical debt, and it is the direct result of building without a thoughtful architecture. There are real stories that illustrate this painfully well. One well-known example is a major Brazilian television network whose website regularly crashed whenever a popular show asked viewers to visit the site. The website worked perfectly under normal conditions, but it was never architected to handle sudden spikes in traffic. Every time millions of viewers showed up at the same time, the system collapsed. The business opportunity was wasted, the brand suffered, and the damage was entirely preventable. These kinds of failures are not rare. They happen across industries, across company sizes, and across every type of software imaginable. And in almost every case, they trace back to poor architectural decisions made early in the project. One of the most famous examples of software architecture done right, after being done wrong, is the story of Netflix. Most people know Netflix today as a smooth, reliable streaming service that works on virtually any device, in almost any country, at almost any time. But it was not always this way. In 2008, Netflix was still a relatively small company, primarily mailing DVD rental discs to customers. Their software was built as a single large system, what engineers call a monolith, where all the different parts of the application were tightly connected to each other. When one part had a problem, it could bring the whole thing down. That is exactly what happened. In 2008, their core database became corrupted, causing a serious multi-day outage. The entire service went down. Customers could not access their accounts, and the company could not mail out DVD orders. This crisis became a turning point. Netflix decided that their existing architecture simply could not support the future they were building toward, global streaming to hundreds of millions of people across every kind of device. They made a bold decision to completely redesign their system from the ground up. Over the next 4 years, Netflix migrated their entire platform to the cloud, rebuilt their system as hundreds of smaller independent services, and designed their architecture to survive and recover from failures automatically. When one small service had a problem, the rest of the system continued working. Users barely noticed. By 2012, Netflix had completed this transformation. Today, their platform serves over 300 million subscribers in more than 190 countries. That level of scale and reliability is not possible without exceptional software architecture. The lesson from Netflix is simple. A good architecture does not just support the software you have today, it enables the business you want to build tomorrow. Netflix is not alone in this story. Amazon has a remarkably similar history. Amazon started as an online bookstore in the mid-1990s. Like most early software projects, it was built as a tightly connected single system. As Amazon expanded from books into music, electronics, clothing, and eventually into everything imaginable, the system grew increasingly complex and difficult to manage. Teams were constantly blocked by each other. When one team wanted to make a change, they had to coordinate with multiple other teams whose work might be affected. Development slowed to a crawl. Deployments were risky. The system became brittle. Jeff Bezos famously sent an internal memo that became known as the API mandate. In it, he made a non-negotiable rule that every team at Amazon must expose their functionality as a clean, independent service that other teams could access through a well-defined interface. Teams were no longer allowed to reach directly into each other's systems. Each team owned and operated their own piece of the architecture independently. This architectural decision transformed Amazon. Teams could now move fast without depending on each other. Each part of the system could scale independently. When one service had a problem, it did not bring down the whole platform. This internal transformation also accidentally created one of the most valuable products in history. By building all these independent, well-defined services internally, Amazon discovered that they had built an extraordinary infrastructure platform. They packaged it up and offered it to the world as Amazon Web Services, Oz, which today is a cloud computing business worth hundreds of billions of dollars. A good architectural decision, made at the right time, did not just save Amazon's engineering team. It created an entirely new industry. So now that we understand what software architecture is and what happens without it, the natural question is, what does good software architecture actually look like? Good software architecture is not one specific design. It varies depending on what you are building, who is going to use it, and what problems it needs to solve. But good architectures tend to share a set of common qualities. Quality 1. Scalability. A well-architected system can handle growth. When 10 times as many users show up as expected, the system can expand to meet that demand without collapsing. Think about how a streaming service needs to handle a completely normal Quiet Tuesday and also the night an enormously anticipated series releases. Both situations must be handled gracefully. Quality 2. Reliability. Good architectures are built to keep working even when parts of them fail. In large systems, hardware fails, network connections drop, and software crashes. These are not exceptional events, they happen constantly. A well-designed architecture accounts for this and makes sure that when one component fails, the whole system does not go down with it. Quality 3. Maintainability. Software is never truly finished. It needs to be updated, improved, and fixed regularly. A good architecture makes the software easy to understand, easy to change, and easy to test. When a new developer joins the team, they should be able to learn the structure of the system relatively quickly, not spend months deciphering a tangled web of undocumented code. Quality 4. Security. A good architecture thinks about security from the very beginning, not as an afterthought. It decides where data is stored, who can access it, how communication between components is secured, and what happens if one part of the system is compromised. Trying to add security to a poorly architected system later is extremely difficult and expensive. Quality 5. Performance. Good architecture considers how fast the system needs to respond and how much data it needs to process. An architecture that is perfectly fine for a small school project would completely fail if deployed for a global bank processing millions of transactions per second. Performance requirements must be understood early and built into the architecture from the ground up. At this point, you might be wondering, who actually makes these architectural decisions? Who is a software architect? A software architect is typically a senior, experienced engineer who has moved beyond writing individual lines of code and now focuses on the broader structure of the system. They are responsible for making and communicating the high-level design decisions that the entire development team will build upon. Think of the relationship between a software architect and a development team the same way you might think about a building architect and a construction crew. The architect designs the overall structure and ensures that all the parts fit together correctly. The construction crew, in this case, the developers, handles the detailed work of actually building it. The architect does not decide what color to paint each room, but the architect absolutely decides where the load-bearing walls go. In practice, the line is not always this sharp. On smaller teams, senior developers often take on architectural responsibilities alongside their regular coding work. On larger teams, there may be dedicated architects who specialize in certain areas, like the security architecture, the data architecture, or the cloud infrastructure architecture. But regardless of job title, the role is the same. Make the important structural decisions, communicate them clearly to the team, and ensure that the system is built in a way that supports both today's needs and tomorrow's growth. A great architect also knows that no architectural decision is perfect. Every choice involves trade-offs. Making one part of the system faster might make it more complex to maintain. Making the system more flexible might introduce performance costs. Recognizing and managing these trade-offs wisely is one of the most valuable skills an architect can have. Let us bring this all the way back to everyday life, because software architecture is actually everywhere around you, even if you have never thought about it before. When you open a food delivery app and your order goes through in seconds, that speed and reliability is the result of an architecture that separates the user interface from the order management system, which is separate from the payment system, which is separate from the restaurant notification system. Each piece works independently. If the payment system slows down briefly, your menu still loads. If the restaurant notification fails, the system can retry without losing your order. When you search for something on Google and get results in under a second from a database containing hundreds of billions of web pages, that is not magic. That is the result of an architectural design that distributes the work across thousands of computers simultaneously, each handling a small piece of the search, and combines the results faster than you can blink. When your bank's mobile app lets you transfer money at 3 in the morning, even though the banking system is running maintenance on parts of itself, that is because the architecture was designed with fault isolation in mind. So maintenance on one part of the system does not affect the parts that customers interact with. When a video game you are playing online stays connected and synchronized with millions of other players around the world, with almost no delay, that is the result of a carefully designed real-time architecture that handles the constant flow of data between every player's device and the central game servers. Software architecture is the invisible infrastructure that makes the digital world run. Every time something just works, every time an app loads instantly, every time a transaction completes reliably, every time a system stays up when you need it, there is a thoughtful architectural decision behind it. Let us do a quick recap of everything we have covered. Software architecture is the high-level structure of a software system, the set of important decisions about how the system is organized, how its parts communicate, and the rules that govern how it behaves and grows. Just like a city needs thoughtful planning before buildings go up, software needs thoughtful architecture before code is written. Without it, systems become slow, fragile, difficult to change, and expensive to maintain. We saw the consequences of poor architecture through real examples: websites that collapsed under unexpected traffic and businesses that suffered as a result. We saw the power of good architecture through Netflix, which rebuilt its entire platform after a catastrophic failure and became a global service used by hundreds of millions of people. And through Amazon, whose architectural transformation created an entirely new cloud computing industry. Good architecture gives a system scalability, reliability, maintainability, security, and performance. These qualities do not happen by accident, they are designed in from the very beginning. A software architect is the person responsible for making and communicating these structural decisions, balancing trade-offs wisely, and ensuring that what gets built today can support what the business needs tomorrow. Software architecture is one of those subjects that, once you understand it, you cannot stop seeing it everywhere. Every app you open, every website you visit, every digital service you rely on, all of them are the visible surface of an architectural decision that someone made. In some cases, that decision was brilliant and forward-thinking, and it enabled something remarkable. In other cases, it was hasty or underfunded, and eventually the system paid the price. Understanding software architecture does not require you to be an engineer. It requires you to appreciate that how something is organized is just as important as what it does. The internal structure of a software system determines whether it will serve people well for decades or become a burden that slows everything down. If you are a student heading into the world of technology, this is one of the most important foundations you can build. If you are already working in technology, a deeper understanding of architecture will give you a new perspective on every system you work with. And if you are simply a curious person who wants to understand the world around you, now you know a little more about the invisible engineering that keeps the digital world running. In our next video, we will start exploring the specific patterns that architects use to solve common problems. Things like microservices architecture, event-driven design, and the pipe and filter pattern. Each one is a tested, proven solution to a familiar challenge, and understanding them will open up an entirely new way of thinking about software. If you found this video helpful, please give it a like, share it with someone who would enjoy it, and subscribe so you do not miss the next one. We genuinely appreciate you watching. Until next time, keep being curious, keep asking how things work, and keep learning. Thank you.